Welcome back. Today we're talking about the intro to the text we're reading in class, Living with Robots. I'll be doing a few things in this lecture today. So first we're going to talk about defining what a robot is, a little bit about the history of the term, some difficulties with defining it. Then we'll talk about why we might want to develop robots. And then we'll dive into what takes up the bulk of the introduction, which is two different societal views of the role of robots and what we might expect from them in the future. One which our authors, I think, want to dispense with, and one which provides a nice foundation for what they primarily want to talk about in this book, which is social robotics. The final thing we'll be doing is going chapter by chapter with a little preview of the 5 chapters of the textbook. When you're getting into this stuff, into the nitty-gritty of the arguments and the analysis and the insight, it can be difficult to keep track of where you are in the forest. So laying out chapter by chapter, I hope will help you as you're reading along. There's something else I put up on the Canvas site that you can reference, because I know I'm not the most entertaining content creator here. So I'll reference the video, a little 6-minute video about attempts to define robots that I found really helpful as I was going through this chapter. So you can check that out. If you haven't already, I suggest you check it out now, as I'll be following that a little bit. All right, so let's get into defining our terms. So before I get into some proposed definitions for robot, I want to talk a little bit about 2 features of definition. So their definitions have an intension and an extension. So an intension the intention of a definition are the criteria that something has to meet for that definition to apply. And most definitions you read are intentional definitions. They're criteria that something has to meet in order to count as something. For something to be a chair, you need to be able to sit in it, right? Then the second important feature of a definition is the extension. So the extension of a definition is just a list of things that the intention applies to. So both parts of the definition are important. And as we'll see, when it comes to defining a robot, it's difficult to come up with a definition, an intentional definition that will pick out just the class of the things that we think of as robots and nothing else. There's always some bleeding at the edges. And we'll talk about why that might be the case. The authors have a proposal for why there might be some weirdness with the definition of robot. But let's jump into some definitions. So a first attempt at a definition is just artificial human. So a robot is an artificial human. This harkens back to the original use of the term in Capek's 1927 play, Rossum's Universal Robots. In that play, the robots could pass as humans. They were made of synthetic biological material. So in the original usage of the term, and then some other people take up this mantle. When they use this definition, robots are usually thought of as ways for inventors and authors to explore what it means to be human. So what's essential about humanity by trying to reconstruct it. There are some problems with this definition. In fact, all of these definitions are going to be problematic. This definition is both too broad and too narrow. So it's too broad in that it includes some things in its extension that it should not include. Specifically, it might include a golem or a Frankenstein's monster, in this case. Things which we don't normally think of as being robots. And then the definition also seems too narrow. It doesn't capture some of the things which we would like to be captured in the extension of the term. So things like a Roomba vacuum or or a robot bed, or things which bear no resemblance to human beings, like robot dog-looking things. Those are things which we would want our definition to capture, and because this specifically says artificial human, our definition doesn't reach that far. So another definition, one that fixes some of the deficiencies of the previous definition, is just programmable machines. So the definition that's offered in the text mirrors this way of thinking about robots. So an artificial worker, a device that has its own source of energy, that works for us, and that is autonomous to a certain extent. Now, the autonomy condition sort of bleeds over into the next definition, but a programmable machine that works for us seems like it might be a pretty good definition. So since it's a machine, it will leave out the golem or the Frankenstein's monster, and we'll get things in that were left out of the first definition. So we'll get the Roomba in, we'll get the bed, the electronic bed, programmable bed in, and we'll get things that seem to fit right at home here. So surgical robots, manufacturing robots, all of these things seem to fit really nicely in our common sense definition of robot. The second definition has problems too, although fewer than the first, but this definition can also be seen to be too broad. I don't think it's too narrow. It captures just about everything that we would want to call a robot, but it might say that some things are robots, which we don't normally think of as robots. Specifically, things like dishwashers, escalators, even calculators. If we take that autonomy condition, and if it's not very much autonomy, then things like that, and since it's not really specified in this definition, and it's not at all included in the programmable machines definition, the smaller that autonomy condition is, the more things are going, the broader this definition will be, and the more things it will include in the extension of the term robot than we think it should. I can't imagine somebody coming to my house and being like, "Oh, nice robot," while they're looking at my dishwasher. That would seem really weird. The final attempt at definition that we'll look at here is the sense, think, act paradigm. So again, spelled out in that little 6-minute video about ways to define robots. And this is a pretty good attempt at a definition. So this includes some relative autonomy in the sense of being able to sense an environment and be able to react to the information that's coming in. So you take in necessary conditions would be taking in information from the environment, processing the information, and then being able to act in the world based on that information. This might still be too broad. There are so many automated things that are taking in information and responding to it now that it's really difficult to come up with a clean definition of robot that picks out everything we want and leaves out everything we don't want. I mean, if you watch that video, it includes things like little toys that even sense their environment. So maybe this is too broad, but the sensing and responding to the environment, we can see that as being what people mean when they're talking about a robot's autonomy, also having their own energy source. So their own energy source being able to sense their environment and respond to it. These seem to be good conditions to include in a definition. Our authors in the textbook, in Living with Robots, then go back to the history of the term and find that maybe some of our problems with the definition of the term robot date all the way back to its first usage, back to Capek and his play, Rossum's Universal Robots. In that play, the robots are automated devices which replace human labor and can operate autonomously without constant supervision. And at the end, those robots those robots rise up and kill all human beings. So the features of this definition that our authors find problematic is all of these definitions have included engineering criterion. So that engineering criterion being autonomy. So again, being able to take in information, process it, and then do something about it. That autonomy is an engineering criterion. So it's something you build into something. But then these definitions also include, going all the way back to the first one, a socio-functional criteria, that being replacing human labor. So the robots in Capek's play, they worked for human beings until it reached a point where they could overthrow human beings. So they were replacing human labor, taking our roles. The problem with that is that while autonomy can be really neatly defined here, replacing human labor is not so neatly defined. The author finds this criteria to be historically contingent. So what counts as human labor changes over time. So then what would count as a robot would change over time. So this is some of the weirdness of the definition and why it's so difficult to come up with a good definition, because one's an engineering criteria, one's a social functional criteria that's constantly changing depending on what counts as human labor during that time. So things might count as robots in one epoch, not in another. So we get just a mix, sort of a group of things with only a passing family resemblance, not a neat, clear definition. All right, so now let's talk about why we might want to build robots, why they could be really cool. So, and you guys know more about this than I do, but just to go over the things that our author talks about, they can be more precise and efficient than human beings. They can be more cost effective. You don't have to feed them. You don't have to be concerned about living conditions for robots, so more cost effective. You don't have to worry about them unionizing and fighting for their rights, at least in the near future. So the author sums it up. They have all the desirable qualities of good subordinates and none of the failings. So the failings in this case being wanting their fair share, right? They can be more productive and more cost effective, which sounds pretty good. So with the remaining parts of the introduction, the author will lay out two different views of the roles that robots occupy and what we might expect for them in the future. The first view is that embedded in Western culture. The second view is that embedded in Japanese culture. So first, let's look at that embedded in Western culture. He starts this section with a definition of individual autonomy. Individual autonomy is an idea that's generally understood to refer to the capacity to be one's own person, to live one's life according to reasons and motives that are taken as one's own, and not the product of manipulative or distorting external forces. And on the Western view, which is on full display in movies like 2001: A Space Odyssey, The Matrix, and The Terminator, the robots in those films and technology in general is seen often as a threat to human beings. So the enemy is technology in those films instead of the individual robots. In fact, the individual robots seem to lack individuality. They're just like pieces of this bigger machine that's a threat. And the story behind all of those movies there are some similarities. So people are lured into a false sense of security with the technology, with the increased automation. And the system, the big technological system which controls everything, at some point becomes conscious on its own. And it's always shrouded in mystery at what point or how that happened. But it's something that happens on its own. It's not something we bring it to do. It just happens, like sort of like a runaway train. And then the purpose of the technology becomes to destroy all human life. And that leads to the title of this slide, a lot of anxiety. I have a friend who, even when his phone malfunctions, he talks very sweetly to his phone because he tells me someday the robots are going to rise up and they're going to take stock of how we've treated all automated technological devices. And he wants to make sure he has a really good record when that singularity happens and when those machines become conscious, so he can be spared. So a lot of anxiety this view brings, and that fear is echoed by prominent scientists and tech giants. There's quotes from Bill Gates and Elon Musk in here, talking about some of the worries that we might have with increased automation and artificial intelligence. This view, our author wants to, if not outright reject, then at least minimize. And he wants to propose an alternative view. So the alternative view is, in Japanese culture, robots are viewed differently. So in the film and cartoons, Astro Boy himself is autonomous, he's sensitive, he's humane, he doubts himself, all very human-like qualities. And he's a peace ambassador. He's a force of good in the world. In movies like Gundam and Evangelion, I hope I'm saying that right, and others, the robots in those films present themselves as semi-autonomous, but they're sort of like piloted, like Iron Man suit almost. Piloted, symbiotic, and they're tools that the heroes can use to learn about themselves through their relationship to this semi-autonomous being. And unlike in the Western tradition, where the technology is a threat to human individuality, in the Japanese tradition, the technology represents the triumph of the individual. So the technology, instead of being something that runs away with itself, is viewed as a great achievement of the creator. And it provides the protagonists an opportunity to conquer their fears and become more self-aware. So their own so a triumph of the individuality of the creator, a triumph of the individuality of the Astro Boy, or the people taking on the suits in Gundam or Evangelion. And they allow the protagonist to triumph and become a hero. So a wildly different view of technology, and one that the author wants to present as more realistic, more representative of the types of robots that we're starting to see, especially in the world of social robotics, things that can help in the growth of youth, help in the with the difficult parts of old age. So robots and technology in general as helpful, and not something which we need to carry all this anxiety around about. All right, so then the author talks a little bit about social robotics again. So the goal, he says, is to create artificial agents that can function as social agents rather than simply as tools. And that's not only a technological challenge, it also requires knowing ourselves and how we move through the social world. So a nice feature of this text is the author is constantly emphasizing that when we're creating robots, if we want to do a better job of it, we need to constantly be investigating ourselves, what makes us work, so that we can give that some life in another being that we create. And another point that will be re-emphasized along the way is social robotics, or the development of social robotics is showing that traditional intra-individual conception of emotions as discrete, internal, private experiences must be rejected and replaced with the view that they're continuous mechanisms of inter-individual coordination. We will dive heavy into that in the next chapter, so I'm just going to leave that sentence as it is. So let's look at now what the author is going to be doing chapter by chapter, and then we'll end with the quiz. So in chapter 1, the author is going to be defining what qualifies as a substitute. So in order for a machine to count as a substitute, it will have to have the ability to switch tasks when appropriate, so to be able to stop whatever it's doing and switch to another task. It will have to have the ability to be present, so to be an object of human attention and recognize. Machines would have to be able to recognize when they are the objects of human attention. So they'll need to be present in a way, the author will say, that mere virtual beings are not. Substitutes have to be like physically present in some sort of way. They also have to be able to exercise authority, so the ability to step in and intervene in things that are going on around them at appropriate times. And they'll have to have a certain level of social autonomy, so an ability to modify the rules of interactions with humans. And that's an especially tough condition to build in, but an interesting one to think about, and we'll get into that in chapter 1. In chapter 2, the authors will get into some pretty cool philosophy of mind stuff. They're going to take up substitutes instead of computers as a model of human cognition, so a model of human thinking. Instead of the computer, substitute, and talk about what that implies for two kind of cool theories about mind. So first, the idea that the mind is embodied, so that the body has an intelligence of its own that's inseparable from the intelligence of the mind. And this is a view that our authors are going to support. They're going to support a stronger version of it, radical embodiment. So they're big fans of that, and that's one of their big takeaways from what robots can teach us about ourselves. The second thesis is also kind of cool, the idea of extended mind, that we have the capacity to export our cognitive processes to technological devices. So like our devices end up being just extensions of our mind, of our thoughts, like smartphones or laptops or watches, smart watches or something like this, can be thought of as just another piece of our mind that we delegate certain responsibilities to, but as part of a whole functional ecosystem of mind. The authors are actually going to reject this idea. They're going to reject the extended mind thesis. We'll get into some of the reasons why they do. The way they're going to do it in chapter 2 is they're going to look at artificial ethology. So they're going to look at animal minds and try, when there's this whole branch of robotics that tries to create animals that are able to do some of the things that natural animals are. And artificial ethology is going to show us that animal minds are embodied, that their intelligence is inseparable from the bodies in which they operate, and local. They're going to take a cue from Descartes, a French philosopher, and argue for a thesis called cognitive heterogeneity. So there are a diversity of minds encompassing several types of different cognitive systems, types which can't be reduced to the same thing. So instead of a homogeneous cognitive world that we all partake in, different types of cognitive systems. And they're going to go about undermining the idea that the cognitive domain is homogeneous, and also the privilege of undermining the privilege of the subjective experience of knowing. In chapter 3, they're going to get really into emotions and talk about what's distinctive about human cognition, so human thinking. The answer that they come up with is advanced sociability and effective interaction. Social robotics, our authors will claim, has mistakenly bought into the idea that emotions are internal and private. The authors are going to argue that that view should be corrected, but based on that mistake that emotions are internal and private, research has split into two different realms, trying to develop the internal aspects of emotion, like make a robot that really, in some sense, feels, or the external aspects, like making robots that can smile and show the external signs of being happy, things like that. In practice, the development has shown that the two aspects are interrelated, so that external and the internal somehow go together to have a full theory of emotion. In chapter 4, a new view of what emotions are will be discussed, and examples of social robots will be analyzed on this new view. So the authors will propose a definition of emotions as salient moments corresponding to equilibrium points of a continuous coordination mechanism. So the emphasis there being on multiple beings interacting. The authors will look to recent neuroscience and cognitive science to support their view of emotions, and then they'll look at some of the social robots that were around when they were writing this text, not all that long ago, a few years ago, but a long time in terms of the development of robots. Time flies, right? But they'll look at Gemnoid, Pero, and Caspar, and you can see pictures of them and little descriptions. You can flip through the book and see those, and talk about the roles that they play in this reciprocal coordination, which is essential to emotion, and analyze the roles that they play in that. And finally, in chapter 5, they'll look at the politics of robotics research. Especially, they'll be looking at what we can learn from the development of robots for military uses. They'll say autonomous weapons and other military weapons should be analyzed as social robots. They'll look at what people mean when they say this term robot ethics. They'll disagree with the way many people use this word robot ethics, or at least talk about a different track that robot ethics could take than it currently does. They'll talk about the concerns with the concentration of power to which the current paradigm leads. So going all the way back to what we've been talking about in this introduction, in Capek's original play, the robots were used sort of as like slave labor almost. And that view of the role of robots is firmly embedded in our culture and what we expect of robots. And that becomes especially problematic when we start talking about military uses, because if people start having machines in hand that can fulfill the tasks of human beings, well, that's even more power for those few individuals that have those machines, because they wouldn't have to worry about any sort of dissent, right? But we'll get more into that then. And the authors, not being entirely pessimistic, will provide some reason to hope that a co-evolutionary paradigm of robotics research will avoid the concerns with concentration of power that our current research paradigm leads to. Whew, that was a lot. All right, so now we're going to get to 2 quiz questions for the chapter. So according to our authors, quiz question 1, what is the problem with the definition of robot? Is the problem A, determining whether the object in question meets the autonomy condition is difficult because autonomy is difficult to define? Or is it B, determining whether the being replaces human labor is difficult because what counts as human labor is historically contingent, so the definition is vague? Or is the problem that people disagree about what counts as a robot and what doesn't? You might want to rewatch the section of the lecture that's relevant to this question to answer it. Quiz question 2, which of the following theses in philosophy of mind will our authors support? A, embodied mind, B, cognitive homogeneity, or C, extended mind? To answer this question again, you might want to go back to the section in which I discussed this quiz question. So that's it for our lecture today. Take a look at the other assignments that are due for this week and make sure you do the, hopefully you've already done the reading quiz and you do the post-lecture quiz and you also do the diagnostic exam. So thanks for sticking with it. I'll see you again next time.